We all have been in the situation where you're working on a production environment and it suddenly crashes. Your pod starts crashing, your environment is down, your users are impacted, war room starts, and you suddenly have to jump in, log into your machine, a lot of time debugging using kubectl commands, get logs, get events, describe pods, and so on. And finally, you find out that there is a bad commit that caused everything. And then you roll back the change and you put the system back to normal. But what if this all hassle, this all can be avoided and can be mitigated as soon as there is a bad commit? What if there is an intelligent agent that could identify and mitigate this issue instantly in the live production environment? Because many enterprise tools, they don't track the diagnosis back to the commit history or the commit ID which actually caused the issue, and there is a huge gap around this, and the gap is this project that we'll be implementing in this video. In this video, we'll be implementing an end-to-end AI observability project on GKE, Google Kubernetes Engine, using Elasticsearch Kibana stack, and we'll be building an AI agent supported by Elasticsearch that will help mitigate this issue end-to-end. Okay, so if you are new here, hello, my name is Piyush, and cloud and DevOps is what I do all day long. I believe in not just theory but the actual hands-on implementation, and if you see my channel, it's full of end-to-end videos, tutorials, and so on. This video is sponsored by Elasticsearch, so thank you Elasticsearch for sponsoring the channel and help us grow. So I'll be providing you step-by-step instruction, I'll be doing the end-to-end demo, and I will share all the links, all the details at the end of this video, so don't worry about it. All the links will be there in the description section. Okay, so let's get into the video. All right, so I have logged into my cluster. So this is a GKE cluster that I have created. I will share all the steps as I've mentioned, and before that, let's just understand what we are going to do in this video. So this is the project that we'll be implementing. It's an end-to-end AI observability project. Okay, so the flow will be something like this. A developer, as soon as the developer merges the code using a pull request, and once the pull request is approved, a GitHub action workflow will be triggered. So there will be a CI/CD pipeline if you are not using Argo CD, right? But in this case, I'm using Argo CD. So Argo CD will pull the changes after every 3 minutes. I guess 3 minutes is the default time, but we can adjust that. So it will pull the changes. Then yes, okay, there is a commit that happened on the main branch, and this Argo CD has the detail which branch to look for, which repository to look for, and so on, and we'll be configuring this. So as soon as it finds that commit, it will deploy the change to the GKE cluster that is running on a GCP project. And at the same time, a GitHub action workflow will also be triggered that will be responsible for sending the event via an index to the Elasticsearch, because in Elasticsearch we'll be creating multiple index so that the retrieval of the logs will be fast. And from this GitHub action, all the details about the GitHub commit that have been done will be transported to Elasticsearch via OTel. OTel is OpenTelemetry, which is an open source framework of transporting logs and metrics to Elasticsearch or to any other logging and aggregation observability system, right? In this case, we are using Elasticsearch and Kibana stack. Now, all the commit history like the commit ID, commit hash, the developer ID, and all the metadata will be shipped to this particular index to Elasticsearch over here via OTel. The same time, when the deployment will happen on GKE cluster, there'll be another index which is responsible for sending logs from GKE to Elasticsearch via OTel, OpenTelemetry, right? So OTel will send two index. One is GitHub action logs, which has the metadata, and another one is deployment and events like Kubernetes events such as create pods, create deployment, create service, and so on. Those events will also be transported to Elasticsearch. Now everything will be there in Elasticsearch. Once it is there, we can check the events that it's coming up or not, right? And then we'll be using Kibana. So here, this one is Kibana, and this is all part of one stack, right? So because we'll be using the GCP marketplace image, it's pre-packaged production image that you can subscribe from GCP directly instead of going to Elasticsearch or any vendor separately. You can directly subscribe a production grade image of a product, a pre-built image of a product from the GCP marketplace itself. So we can use that, and then in Elasticsearch we have an option to create the agent builder. Agent builder will have multiple tools. in which we configure certain type of errors, and those errors will be tracked by Agent Builder. It will check and it will trace it back to the GitHub commit that could have caused that issue. Okay, so let's say we are getting OOMKills error in one of the pods. Okay, now it started after a commit. Maybe someone has increased the request and limits of a pod, and when that person did that, it created a bad deployment. The deployment will be recovered instantly because we have Argo CD deployed, reconcile the changes. It will revert the changes back to the healthy deployment. But we also want to know what happened over here, why the pod failed even for a few seconds, why did it happen? So we can track all of those using the Agent Builder that we'll be configuring. Inside Agent Builder, there will be a couple of tools that we'll configure. This is when we are using Argo CD. So in this case, we are just identifying the root cause, what could have caused the outage. But if it was not an Argo CD, if it was a CI/CD tool, this could have caused the outage. In that case, we can add additional step to mitigate the issue as well, right? So yeah, so this is what we'll be implementing. So yeah, let's go ahead and let's check the GitHub repo. All right. So here are some of the prerequisites for this project. You should have some CLI tool installed because we'll be running most of the commands through CLI. So Google Cloud SDK, gcloud login. Like if you are on Mac, then you can use this. If you are on Linux, then you can use this. You should have kubectl installed because we'll be using kubectl commands. Otherwise, you can do it from the Google Cloud Shell as well if you don't want to do that. Okay, then Helm to install a few components. Then Argo CD client, because again we'll be running Argo CD commands, GitHub CLI command, and Git client. Okay, all those things. Few of them are mandatory, few of them are optional. It depends on you how you want to implement it. If you are using VS Code or any IDE to run all these commands, then it is recommendable. Like these commands are really important to understand. Then you can just go ahead and create your GKE cluster. I have already created the cluster in advance to save some time. Then you can connect the cluster and verify the connector, and then here are the steps to install the online boutique application. Okay, before that, let me just try to connect the cluster from here. Let's go inside the cluster, hit connect, and it will pop up with the command. Okay, let's just copy this command, and I'm gonna go back to my VS Code and I'm gonna paste the command over here. There are some special characters, so let me just paste it again. All right, and hit enter. I'm sure this will be a little small font, but I have to show the entire screen. So get nodes. Okay, I have 3 nodes running up and healthy. Now to deploy the application, here are the commands. First, you can just clone this repo and go inside this particular folder. I'm already inside this. I have already cloned the repo, and this repo will have the microservice pre-configured for you to use. Now what we need to do is we need to create a deployment from the marketplace. Okay, so let's go back over here in the GCP console and search for marketplace. Okay, product. Now inside marketplace, you need to search for Elastic, and you will see the first result, which is over here, and it says Elastic Cloud Elasticsearch Service. Okay, just click on that. You will see the official Elastic Cloud logo, and this is how you know, like this is what you need to do. Now click over here because I have already used the trial period and now I am on pay-per-use plan. But if you are using it for the first time, you will be getting a 7-day trial. So you can just click over here to subscribe. Okay, now subscribe button is not there again because I have subscribed to it already. Now then click on manage on provider, and then it will redirect you to the official landing page of Elastic Cloud. Okay, and then you can sign up. If you are using for the first time, you can sign up. If you are using for the other time, like if you have used it before, then you can just use sign in. Okay, now I'm gonna put my email details over here. Okay, so once you log in using the sign up that you did, you will be redirected to cloud.elastic.co, and these are the options that you will see. So I'm gonna click over here which says create hosted deployment. Over here you will see 3 solution type. One is Elasticsearch. Okay, it will include build, search, and vector database. Then there is Elastic for observability. So this is an end-to-end observability solution with logs, AI Ops, APM, SLO, synthetic monitoring, and so on. There is a security focused product as well, but we don't need that. What we need is this one, which says Elastic for observability. Okay, then hit next and give it a name. Let's call it demo deploy. leave everything as default. Basically, it is showing which cloud provider you are choosing to host your deployment on, region, and so on. Like, I'll just leave it default and hit create hosted deployment. Now it will take around 5 minutes for the deployment to be provisioned, but make sure you copy this password from here. Copy or download, whatever. This is for the Elastic username. Okay, so after a few minutes, it says the deployment is ready. So let's click on continue over here. And now it will redirect you to the deployment page. All right, here are all the options. This is your Elastic deployment, and it will have observability and dashboard, many other features, and we'll see few of them. Now it says add observability data and what you want to monitor, or yeah, there are multiple options like host, Kubernetes, application, cloud. So let's go ahead with Kubernetes. And over here, we see two options: monitor your Kubernetes cluster using Elastic Agent or OpenTelemetry. So let's use this OpenTelemetry. OpenTelemetry, as I've told you before, it's an open source framework which collects the log from the source system, Kubernetes in this case, not just logs, traces, metrics, etc. And then it will transport that to Elasticsearch or any other third-party system for further analysis like log aggregation, processing, and then visualization and so on. Right? So this is what we'll be using. Now it will provide you some commands that you will be running in your cluster, and which will create the link of OTel to your cluster, or which will install the OpenTelemetry operator to your cluster. Okay, it's a Kubernetes operator which is packed with multiple resources like custom resource definition, custom resources, deployment services, and so on. Right? So first step is to add the OpenTelemetry repository to Helm. So let's copy the first command and we'll go back over here and run this command. Okay, it says it's been added. Now let's go back, and now we're gonna copy this command, and in this command, if it's not visible, I'll just increase the font. It says create the namespace for OpenTelemetry, create a secret. In the secret, we have Elastic OLTP endpoint and Elastic API key. These details you can also get it from here. I will show you how you can do that. But for now, you can just run this command as the way it is. So let's just copy this to clipboard, and I'm gonna execute it over here. Okay, so we got Elastic endpoint, OLTP ingest endpoint. We'll get it right. And then we have API key. Then we have, okay, so these are the steps that we have already performed. And then we'll be doing the GitHub workflow. We'll be looking into the GitHub workflow after that. And then there is a sample index that we'll be creating, and add GitHub secrets. All right. So let's go back first. And so yeah, this is done. And now there are some optional steps as well if you want to instrument your application or visualize. For now, this is fine. We just wanted to do that. And let's just say if all the objects are running. So if I just kubectl get all hyphen namespace, and namespace name was where it is. Okay, over here. Okay, so it has 3 replica sets, 3 deployment, everything is up and running with 3 pods for each daemon set as well. And there are some services that has been created. And yeah, all the pods are running. Okay, so we are good with that. Now let's check the GitHub flow. Okay, so inside .github folder, there'll be workflows. Inside that, there'll be index deploy. Okay, so this is what it will do. Let me just show you this. Okay, so I'm sure you are aware of how GitHub action works. So it's basically a CI/CD pipeline that gets triggered based on certain condition, and it does certain things. In this case, what we are doing with that GitHub action, transporting the metadata of GitHub commit to Elasticsearch so that we can trace back the diagnosis with the GitHub commit history. Okay, so it says on push branch, so it will trigger on the main branch push, runs on Ubuntu latest, and then it will have one stage which says detect change service. Okay, and this is basically getting all the metadata that it needs with some regex. Okay, git diff, and then from the head and from the manifest. Okay, and Then it will push the deploy event to Elasticsearch using the secrets that we have configured. There is an Elasticsearch endpoint that we'll be configuring right now, and there'll be Elasticsearch API key. And along with using that, it will store timestamp, commit SHA, author, service, image tag, change, which is the commit message, and the diff URL so that we can compare. And that's it. It's a small workflow which will does all the things that we need. Okay. Now let's go back over here. So first we'll create the index. Now this has already been configured in your project. So whenever you push the changes to GitHub, it will auto trigger for you. What you need to do now, you need to create the index using this curl command. Okay. Make sure you add your API key and Elasticsearch endpoint over here before running this. And from where do you get it? Let me show you that. Okay, let's go back over here and let's go to the deployment. Manage the deployment. Okay, over here you see it says application endpoints cluster and components ID. So from each of these buttons you can get the API keys and endpoint details. For example, if I need Elasticsearch details, so click over here, copy the public endpoint from here, you can just paste it over here. Okay, and the next thing we need is the API key. So to get the API key, what we need to do is let's open Kibana from here. Okay, and Kibana and Elasticsearch, it will be on the similar endpoint. So if we click on that, we'll be going to this page that says it's basically the Elasticsearch endpoint, and Elasticsearch and Kibana both will be present over here. But what we need is go over here to the settings at the very bottom left. Okay, and click on security. Somewhere down over security, inside security, there is API key. Click over there and hit create API key. Let's call it test. Okay, and hit create API key. Now the key has been created. Make sure you copy it from here and let's go back. Yeah, and I can paste it over here. Okay, now run the command again to create the index. Okay, now it worked. It says acknowledgement true, shard acknowledged true, and index is this GitHub deployment. Okay, so that has been completed. Now let's proceed further with this document. Now we need to configure GitHub secrets. Okay, over here we need to provide Elasticsearch endpoint, and in this secret command we need to provide API key. So let me just paste the API key over here. Okay, and you can like add the secret from the GitHub UI as well. I'm just using the CLI so that I can share easily with you. Okay, it's your wish. Now with this command I can run to create the GitHub secret. Yeah, it says it's been created. Now I need GitHub Elasticsearch endpoint, which I can copy from the previous command. You can store it somewhere and then you can reuse it, or store it in an environment variable and reuse it. It will be easier that way. Okay, and let me just paste it over here. Make sure you add the HTTPS as well, and 443. Okay, now let me run this command to create the GitHub workflow secret for Elasticsearch endpoint. Now these two have been created. Now we can test the changes. To test the changes, we can just push an empty commit to the repository, or you can put like a valid commit as well. We just need to test the changes. So let's say test 2.0 verify ES indexing. That's the commit message that I'm putting. Okay, it's done, and then I'm just gonna push the changes. So once the changes are pushed to the main repository, GitHub action workflow will be triggered. Argo CD will pull the latest changes. It won't find anything, so it won't do anything. But GitHub action will still send the GitHub metadata, the commit metadata, to Elasticsearch via OTel. So that's what we need to check. Okay, you can run this GitHub run list command to check the latest commit details. Okay, and yeah, let's see, 9 seconds ago it shows you this is the commit that has been recently done. And now you can verify if the doc is landed. I mean, you can run this command. I'm just gonna skip it for now. Okay, now the next step is let's go ahead and set up Argo CD. So over here are the commands. So first it will create a namespace for Argo CD. It will apply the manifest. It will roll out the deployment, and then it will expose the service via load balancer. Yeah, so let's run till here and then we'll get the admin password. All right, let's run the get service command to get the external IP, which is over here. And now I can just put the external IP over here to do the Argo CD login. Before that, we need the Argo CD password, which can be obtained using the get secret command from here. And it is an encrypted, actually not encrypted, it is the encoded password. So I'm just gonna put it over here and I'll be doing Argo CD login. Now make sure you have Argo CD client installed on your local machine, otherwise Argo CD command won't work. Okay, the login has been done. Now you need to create the application using Argo CD. So online boutique application will provide the source repo URL. In this case, source repo URL is my repo. Make sure you add your repo URL by uploading the application in your repo, or you can fork this repo and then make sure you update this repo URL. And here's the destination. This is the destination server, which is the Kubernetes service. Namespace is online boutique. Prune is true and sync option is create namespace is true. Okay, that means it will create the namespace if it doesn't exist. So I'm just gonna copy this command and run it over here. Okay, it says the application has been created. This is the Argo CD output. Now you can sync the application with this. Otherwise, it will sync automatically after a few minutes, but you can just force sync using Argo CD app sync command. Okay, and then you can patch the poll interval from 3 minutes to 30 seconds using this kubectl patch command so that we can test out the changes and then we can save some time over here. And then let's just do the rolling restart. Okay, now let's run and verify if all the pods are up and running. I'm just gonna add a watch at the end. Okay, running. One load generator is like init container is still coming up, but that's okay. Like we don't even need that for now. All right, now we'll be proceeding further to create the tools in the agent builder. We'll be following these steps. This is the tool name, get crash log that we have provided. This is the language. This is the index because index we have already added in the query. So let me just copy this name. Okay, so over here we click on new tool. Okay, new tool. This is the type. Okay, and over here you need to provide the query language, which is, I can just take it from this particular repo, and it's ESQL or Elasticsearch SQL query language. Okay, so it's more of like MQL that we have in GCP, which is monetary query language. Starts with from logs pattern, the table pattern, and then separated by pipe with where keyword, where namespace name equal to this, where body.text like OOMKills or memory, sort by timestamp and limit as 20 and keep all those things, right? So we need to create separate tools for each of the patterns that we have identified. These patterns are the frequently caught errors or identified patterns that we have for the frequently analyzed issues, right? So click on that and hit save. Okay, we need to provide the tool ID. So let's just give it a name, which is get crash logs, and description is also okay. So OOMKills errors. Okay, let's try to hit save now. Okay, it's saved over here. Let's go back. We need to create another tool, which is for get deployment history, which is basically from the GitHub deployment index. Okay, so this index we created earlier, if you remember. So I'll just gonna copy this. Let's go back. Okay, create new tool. Add the query over here from GitHub deployment. This is the index. And let's go back and hit save. Let's give this name get deploy history. Okay, hit save. Okay, so we have created both the tools. Now the next step is to create the agent and add those tools inside that agent. Okay, let's call the agent as this blame the deploy. Okay, and you can search it again from the agent builder. From here, let's call it create agent, inside agents, and yeah, Elastic AI agent. And this is the default. Okay, click over here, new. We are creating new agent, agent ID, which is the name. Okay, blame the deploy. Over here you provide your custom instructions, which is basically the master prompt that you are providing to the agent that it will be using all the time. Okay, so over here are the instructions. You are an SRE agent. When asked why a service is crashing, use these tools and look for these logs and provide the details, right? So we are providing these instructions and feel free to modify as per your needs. I'm just trying to keep it simple. Okay, and that's it. Let's hit display name and description. Okay, display name, let's give this a display name. Let's add the same in description and hit save. Okay, so now we have configured 2 tools and 1 agent. Let's move forward now. In the tool section, add tools, select get crash log, add tools again, select get deploy. Oh, in the tools we forgot to add, so let's just modify this. Where is the tools section? I don't see it. Okay, over here, my bad. Okay, let's search for GitHub. Oh, it's not available. The agent has 5 active tools. Like these are the existing tools already, but this is not what I want. I want one was get crash logs and get deploy history. Okay, get crash logs, get deploy history. Okay, these are the 2 tools. Let's save. Agent has been updated successfully. Now we need to run the demo. So what we can do is we can go to our Kubernetes manifest. Okay, and let's just change the resource request, memory, and limits. Okay, so let's just put it like, let's just make this change 24. Okay, so I'm gonna go to my GitHub and search for that repository, which is AI Observability. Okay, and inside that release, inside Kubernetes manifest, I'm just gonna make the changes directly from here. Okay, and let's find the memory request and limits. Okay, I think this one would work. Which service is that? Currency service. Have we mentioned which one? I mean, I'm following this one because this I've already tested. Okay, so payment service. Let's just search for payment. Okay, payment service over here, and inside that over here. Okay, so memory is 24 MI. Memory is 24 MI. I think this is the new one. Okay, I have already updated it earlier. So if I do kubectl get deploy -n online boutique. Okay, payment service, it is running fine, no issues with that. So let's make some change over here. OOMKills will happen when memory utilization is greater than the limit. Okay, so let's say request is 24 and let's keep limits as 12 MI. Okay, this should work. To optimize memory, commit to the main branch, and we'll just wait for Argo CD to sync the server, and then we'll see if there is any crash or not. We can check the Argo CD as well over here. So kubectl get svc -n Argo CD server. I believe that's the namespace name. No. Get all Argo CD. Okay, yeah, this is the one. Let's check the service, which is over here, Argo CD server. Now over here, password should be from, there was a secret. So I think kubectl get secret. Let me just find the command from here. Okay, this one over here. From here, I'll get the admin password. Okay, so it says out of sync and it is syncing because I just made a change. It detected the change and now it is syncing. So let's just check that application. It came up healthy. We'll check the payment service synced and let's see if we see any changes. Payment service. Okay, over here. And inside that, let's check the request. So 2424, it might have reverted the changes. No, an hour ago. Logs. No, let's try to sync it. Maybe it did not detected it. Oh, it's still syncing. Okay. Okay, it says payment service is invalid because for the obvious reasons. Okay, and it might not make the change. Yep, so here are our changes, but that's the desired manifest. It won't make the change. And here's the diff. Inside diff we'll see this was the change that was done. Okay, so it says, oh, that's just the transaction error, so ignore that. Because this is kind of a real-time simulation of an online banking application. It is generating some load on the service. Yeah, let's go and check over here if the service is kind of getting synced or not. Okay, so what we did is we made this change, we committed the change, and if we check, the pod is getting restarted again and again, if we can see. So what we'll do is, instead of running commands over here, what we'll do is we'll ask the agent. Okay, so we'll go over there, we'll select the agent, and then we can just ask this. Let's go ahead over here. Okay, and agent builder over here. Let's go to our agent. Let's chat with the agent. Okay, so by default it is using Claude Sonnet 4.5. This is the agent that has selected, and we can just ask, why is payment service crashing? Check the logs and recent deployments. Okay, and now it has all the context. It has access to all the logs that it needs, the GitHub action logs, as well as the logs from the Kubernetes deployment. It has the event logs as well, and this agent is running inside Elasticsearch, doing all those things using the tools, because that agent has been configured with multiple tools. So it is calling all the tools and gathering all the information. Okay, it found something. It says, based on the investigation, I found a recent deployment that is likely causing the issue with the payment service. Here was the time, here was the commit SHA. Author was, of course, myself. This was the change. This is the diff URL, and likely cause is this. Memory limit is set too low, causing OOMKills. So it provided the entire root cause analysis with exact details that we needed and the steps to fix it. Okay, now the next step is, how do we fix it? I mean, we can go ahead and fix the changes, and then we can ask the agent again, is payment service healthy now? Okay, so let's go ahead over here, and inside this, let's click on edit, search for payment service. Okay, and over here I'll just increase the request limits, and okay, let's call it 100 mi and 100 mi. Commit changes, fix the OOMKill issue. Okay, hit commit. Now I can just force sync over here. Sync failed because again there was a sync in progress and it committed the change again. It is progressing again. We can just force sync it again if you want, or we can just wait for it to sync it. Okay, it's synced, I believe. Let's go ahead and let's run the command again. Okay, now we see it's running 11 seconds ago. Oh no, it's still coming up. The container is not up yet. We see 0 out of 1 and now it is up. Okay, now let's go and ask the question again from the agent. Is the payment service healthy now? So after fixing the issue, I asked if you see an OOMKill event now. It says no, I cannot see OOMKill event because it isn't available in your Elasticsearch cluster. System is trying to query for crash log, but required field does not exist. Because you see, when we created that tool using the query language, we only specifically did that for OOMKill message. Any other messages or any other type of logs would not be ingested, right? So we need to create some sort of patterns that the entire kubectl event logs or any error message should be transferred to the Elasticsearch cluster, and then we can run all these agent diagnostic on that. I hope you found the video valuable and helpful. And if you did, let me know in the comment section. I will share all the links, GitHub repo, how to sign up, and everything inside the description of this video and the comment section as well. So go check it out and let me know. Thank you so much for watching. Keep supporting, keep learning. Happy learning.